Here is the first question of the exercise 13.2, and the question is, he has given probability of A and probability of B, and we need to identify the value of probability of A intersection B, and also he has given that A and B are the independent events. We know that when two events are independent or two events A and B are said to be independent events if probability of A intersection B is equals to probability of A into probability of B. So directly substitute the value of probability of A. The value of probability of A is 3 by 5 and probability of B is 1 by 5. So therefore, required value probability of A intersection B is equals to 3 ones are 3 divided by 5 into 5, 25. So required probability of A intersection B is equals to 3 by 25. I hope all of you understood. Now let's start the next question. And the next question is, two cards are drawn at random and without replacement from a pack of 52 playing cards. Here, in this question, he is taking two cards in without replacement manner from the pack of 52 playing cards, and we need to identify that probability that both the cards or both the drawn cards are black. See here, from the 52 playing cards, he is taking two cards. And what is the probability of first card is a black card, and what is the probability of second card is also black card. And these two cards are drawn in without replacement manner. Therefore, required probability is equals to. Therefore, required probability is equals to probability of the first card is black and probability of the second card is also black. So we know that number of black cards is 26 out of 52. Therefore, probability of first black card is 26 by 52 into, since these two cards are drawn in without replacement manner, therefore now remains 51 cards in the pack. Therefore, probability of second black card is 25 divided by 51. So out of 26, one card is drawn in the first chance. So remaining 25 black cards out of 51. Therefore, required probability is equals to 26 ones are 26 twos are, which is equals to 1 into 25, 25 divided by 2 into 51 is 102. So 25 by 102 is the required probability. I hope all of you understood this. Now let's start the next question. And the next question is a box of oranges. Here one of the interesting question. A box of oranges inspected by examining the three randomly selected oranges drawn without replacement. If all the three oranges are good, then only the box is approved for sale. Otherwise, it is rejected. See here, if you want to sell the box, first thing he has to inspect by taking three oranges from the box at random without replacement. If all that drawn three oranges are good, then only the box is approved for sale. Otherwise, it is rejected. This is the given information in the question. And the question is, find the probability that a box containing 15 oranges, a box containing totally 15 oranges, and in that 15, out of which 12 are good, so 12 are good, and remaining 3 are bad ones. Remaining 3 are bad ones. So there is a one box which contains 15 oranges. Out of 15 oranges, 12 are good and 3 are bad ones. And the question is, will be approved for the sale. So we need to identify the probability of the box is sale. If you want to sell the box, so whatever you draw, that three oranges must be good. So therefore, required probability is equals to, therefore, required probability is equals to, see here, to check whether the box is approved for sale or not. He has to draw three oranges at random without replacement. Without replacement. If all that three oranges are good, then only the box is approved for sale. Otherwise, it is not. So it means here we are identifying the box is approved for sale. In other words, all that drawn three oranges must be good. It means required probability, the probability for approving the sale is probability of the good orange into probability of the second good orange into probability of the third good oranges. If you all that three drawn oranges are good, then only the box is approved for sale. So that's why required probability is probability of good orange into probability of good orange into probability of the good orange. Now see here, probability of the first good orange is total number of oranges in the box is 15. Out of 15, 12 are good. So probability of the first good orange is 12 by 15 into probability of the second good orange. Since the experiment is taking in without replacement manner, therefore probability of the second good orange is 11 divided by 14 into probability of the third good orange is 10 divided by 13. Now see here you can cancel 3 fours are 3 fives are 5 ones are 5 twos are 2 ones are 2 sevens are. So therefore required probability is equals to 4 into 11 44 divide by 7 into 13 91. Therefore 44 divided by 91 is the probability of the box is approved for sale. I hope all of you understood this question. Now let's start the next question. And the next question is, a fair coin and unbiased die are tossed. As you know that unbiased die means normal die. A fair coin and an unbiased die is tossed. When a coin is tossed, there exist two possibilities, either H or tail. And when a die is tossed, we have six possibilities, 1 to 6. Therefore, the sample space of this experiment, S is equals to, along this H, you may get 1, 2, 3, and so on, so 6. Therefore, H1, H2, H3, H4, H5, H6. Or you may get tail, and along with tail, you are going to get either 1, 2, or 6. Therefore, next possibilities are T1, T2, T3, T4, T5, and T6. So these are the 12 possibilities when a die and a coin is tossed. Therefore, the number of outcomes in the sample space is equals to 12. And now he has given that A be the event, head appears on the coin. So here A is one of the event which consists the outcomes in which the coin gets head. Therefore, outcomes of the event A is either H1, H2, H3, H4, H5, H6. So these are the only 6 possibilities in event A, because event A itself says that head appears on the coin. And next he has given that B be the event 3 on the die. B is the event 3 on the die. So in which outcomes 3 appears on the die, that outcomes are exist in event B. So observe here only two outcomes, H3 and T3 has 3 on the die. Therefore the outcomes of the event B is H3 and T3. So these are the given events, and in this question we need to check whether A and B are independent events or not. So as you know that independent events means probability of A intersection B should be equals to probability of A into probability of B. If probability of A intersection B equals to probability of A into probability of B, then we say that these two events A and B are the independent events. So therefore, first we need to identify the probability of the event A. So from this event, we may write the probability of A event. So observe here, event A is head appears on the coin. So observe here, event A consists totally 6 outcomes out of 12. So therefore, 6 divided by 12 is the probability of the event A, or you may say that 1 divided by 2. And similarly, probability of the event B is equals to 2 outcomes in B, total number of outcomes 12. So therefore, 1 by 6 is the probability of the event B. And we need what? Probability of A intersection B. So first we need to identify A intersection B. So A intersection B means common outcomes in A and B. So observe these two events A and B, there is only one common outcome, that is what? H3. Therefore, A intersection B consists only one possible outcome H3, which implies probability of A intersection B is equals to 1 divided by 12. I hope all of you understanding. Now to check whether these two events are independent or not, now consider. Now what? Consider what probability of A into probability of B as per as the definition of independent events. And observe here probability of A is 1 by 2 into probability of B is 1 by 6 and 1 by 2 into 1 by 6 is 1 by 12 and 1 by 12 is the probability of A intersection B, which is equals to probability of A intersection. So finally we got probability of A intersection B is equals to probability of A into probability of B. So which implies events A and B are independent events. Are independent events. I hope all of you understood. Now let's start the next question. And the next question is a die marked 1, 2, 3 in red. So there is one die. On that die, numbers 1, 2, 3 are marked in the red color. 1, 2, 3. So these three numbers on the die are marked with the red color. And 4, 5, 6 in green and 4, 5, 6 numbers 4, 5, 6. These three numbers are marked in green color are tossed. So when this die is tossed, the possibilities are same thing. 1, 2, 3, 4, 5, 6. Either we may get 1, 2, 3, 4, 5 or 6. This is a sample space of the experiment when a die is thrown. And let A be the event. A be the event. The number is even. See here, A is the event depends on the numbers. The numbers are even. Therefore, event A consists only even numbers 2, 4, 6. And B be the event. The number is red. So B is an event which consists the numbers which are in red colors. So as you know that the numbers in red colors are 1, 2, 3. 1, 2, 3. And the question is, are A and B are independent? So we need to identify whether these two events A and B are independent or not. So first, directly we may write the probability of A event. Probability of A is equals to 3 by 6, which is equals to 1 by 2. Similarly, probability of B is equals to, it is also equals to 3 by 6, which is equals to 1 by 2. Now we need what? Probability of A intersection B. So for that, first we need to identify A intersection B, common elements in A and B. So observe here, there is only one common outcome in A and B, that is what? 2. So which implies probability of A intersection B is equals to 1 by 6. I hope all of you understanding. Now, to identify whether these two events are independent or not. So let us consider probability of A into probability of B. So observe here probability of A is 1 by 2 into probability of B is also 1 by 2, which is equals to 1 by 4. But probability of A intersection B is 1 by 6. It means this is not equal to probability of A intersection B, which implies A and B are not independent events. Are not independent events. I hope all of you understood this question. Let's start the next question. And the next question is, let E and F be events with probability of E is equals to 3 by 5 and probability of F equals to 3 by 10 and probability of E intersection F is 1 by 5. The question is, are E and F are independent? So directly he has given the value of probability of E intersection F here. So just identify the value of probability of E into probability of F. So probability of E is 3 by 5 into probability of F is 3 by 10, which is equals to 9 divided by 50, and 9 divided by 50 is not equal to probability of E intersection F, because probability of E intersection F is 1 by 5. So since probability of E intersection F is not equal to probability of E into probability of F, which implies E and F are not independent events, are not independent events. I hope all of you understood this question. Now let's start the next question. And the next question is, see here, one of the important question. So in this question, he has given that events A and B are such that probability of A is equals to 1 by 2, probability of A union B equals to 3 by 5, probability of B is equals to P. Find P if A and B are the mutually exclusive events and when A and B are the independent events. So here he has given that the probability of A, probability of A union B, but probability of B is given in unknown quantity, and we need to identify the probability of that B. When the first question is when A and B are the mutually exclusive events. The first question is what? When A and B are mutually exclusive events. Exclusive events. See here, we say A and B are the mutually exclusive events if A intersection B is equals to null set. If intersection of both the events is equals to null set, then we say that A and B are the mutually exclusive events. So when A and B are the mutually exclusive events, we know that the formula for probability of A union B, formula for probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B irutta. Since A intersection B is null set, which implies probability of A intersection B is equals to 0. That's why probability of A union B is equals to only probability of A plus probability of B. Just substitute the given values here. Here the probability of A union B is 3 by 5, which is equals to probability of A is 1 by 2 plus probability of B is P, which we need to identify here. Therefore, just observe here, 3 by 5 minus 1 by 2 is equals to P, and the LCM of 5 and 2 is 10. Here multiply by 2, here multiply by 5. So 3 into 2 6 minus 1 into 5 5, divide by LCM is 10, which is equals to P. So which implies 6 minus 5 is equals to 1, divide by 10 is equals to P. So required value of P when A and B are the mutually exclusive events is 1 by 10. I hope all of you understood. And here is the second question. We need to identify the value of P when A and B are the independent events. Now the second question is what? When A and B are independent events, are independent events. As you know that independent events means probability of A intersection B is equals to probability of A into probability of B. So this is what he has given in this condition. So now to identify the value of P, first we know the formula. That is what? Probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. So therefore probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B is probability of A into probability of B. So now just substitute the given values here. Probability of A union B is 3 by 5 equal to probability of A is 1 by 2 plus probability of B is P minus probability of A is 1 by 2 into probability of B is P. So now by this equation we need to identify the value of P. So just shift this 1 by 2. 3 by 5 minus 1 by 2 is equals to P minus 1 by 2 P. LCM is 2, so here multiply by 2. 2P minus 1P divided by 2. So as you know that 3 by 5 minus 1 by 2 is equals to 1 by 10. So 1 by 10 is equals to 2P minus P is P divided by 2. So therefore the required value of P is equals to, by the cross multiplication, 2 by 10 is equals to P. So therefore 2 ones are 2 fives. So therefore required value of P when A and B are the independent events is 1 by 5. I hope all of you understood. So this question is important question. And the next question is, A and B are the independent events with probability of A is 0.3, probability of P is 0.4. Then we need to identify probability of A intersection B, probability of A union B, and probability of A by B as well as probability of B by A. See here he has given that A and B are the independent events. Therefore, the first question, probability of A intersection B should be equals to probability of A into probability of B, and which is equals to probability of A is given 0.3 and probability of B is also given 0.4. So which is equals to 0.3 into 0.4 is 0.12. So therefore required probability of A intersection B is 0.12. And now the second question, probability of A union B. Now what? Probability of A union B, which is equals to probability of A plus probability of B minus probability of A intersection B. So these values are already known. Probability of A is 0.3 plus probability of B is 0.4 minus probability of A intersection B is 0.12, which is equals to 0.3 plus 0.4 is 0.7 minus 0.12. So therefore required probability of A union B is equals to 70 minus 12 equals to 0.58 ಆಗುತ್ತೆ. 0.7 minus 0.12 is equals to 0.58. And now the third question, here we need to identify probability of A by B. Now what? Third one, probability of A by B. ಇಲ್ಲೇ ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ. Now the third question, probability of A by B. And the formula for probability of A by B is probability of A intersection B divides probability of B. So which is equals to probability of A intersection B is 0.12 divided by probability of B is 0.4 and which is equals to 0.3. 4 ones are 4 threes are 12. So therefore 0.3 is the required probability of A by B. And similarly we need the fourth one, that is probability of B by A. And its formula is probability of A intersection B divides probability of A. And the value of probability of A intersection B is 0.12 divides probability of A is 0.3. So same thing, 3 ones are 3 fours are. So 0.4 is the required value probability of B by A. I hope all of you understood this question.